This conference will now be recorded.
Okay, so let me share my screen. Yeah. So good morning, guys. So welcome to fourth lecture on prestressing concrete structures. So we are, you know, going through a lot of in-depth, concepts in prestressed concrete structures. Today we are going to cover a few more topics from the first module. So they are prestressing concept, materials, and prestressing system. Okay. So yesterday we gone through what are the different types of prestressing systems like pre-tensioning and post-tensioning, right? So along with that, there are other mode of pre-stressing. Okay, they are not systems. I can call it as other modes of pre-stressing. So that we are going to discuss along with what are the materials required for the pre-stressing. Okay, so if I can complete this particular lecture in 1 hour, or I can, or else we will continue the same presentation. Even for the Saturday's class as well. Okay, right. So let me start first with basic concepts of pre-stressing. See, so what are the basic concepts of pre-stressing? There are three different concepts. So where the pre-stressing is supposed to be, happen. So there are three basic concepts. The first one is pre-stressing to transform concrete into an elastic material, isn't it? Right? So here we all know concrete is a brittle material, but still it will have few elastic properties. So here what we are going to do in the first concept, we want to make that we have to transform concrete into an elastic material. Then only you can able to squeeze concrete towards upward direction, right? And the second one is the pre-stressing, where the combination of high strength steel with concrete. So there should be a combination, right? So without pulling strands, you can't compress concrete element, isn't it? So that is the second concept. And the third one is pre-stressing to achieve load balancing. So what is the third one? So why we are doing all this? So to achieve load balancing. So that means it has to balance the load. It has to balance the stresses, right? So concrete, it will attain its compression stress, okay, and it can able to carry the load which is acting on the member, okay. So that is what the third concept. So here these are the three basic concepts why the pre-stressing is supposed to be done, okay. So please try to remember these three concepts, okay, why we are doing pre-stressing, if anyone questions you, okay. Right. And the next one, advantages of pre-stressing. I think we already discussed these in the previous class. So let me just show you glance in detail. Why? Because in theoretical exams, like in your external examinations, this is one of the important questions. Okay, that is the reason why I gave in brief about the advantages of pre-stressing, because in the previous class we already gone through the limitations also, isn't it? So here the advantages, in the sense, one, section remains uncracked under service load. So we have to make the section which is going to be uncracked, okay, even under the service loads, right? And for that in detail you can able to go through the slide easily, okay, because we already discussed it. So here reduction of steel corrosion, which improves the which improves non-cracking of the particular element, and full section is utilized. As I told you, the whole length of the member is going to be act as a single unit, okay. It is not like the center portion, it's not like the end portions. The whole length of the longitudinal member is going to be act as a single unit, okay. And so where high moment of inertia and less deformations is going to be happen under the service load when you go for pre-stressing. So that's the biggest advantage. And it increases the shear capacity also. Yesterday, one student asked me, so what about shear? See, when you do pre-stressing, it improves the shear capacity along with the flexural strength. Okay. So here it is suitable for using pressure vessels, liquid retaining structures, because we already gone through the applications of pre-stressing in the olden days, like barrels which are supposed to be tipped with metal, and rim which are fixed with some spokes. Okay, so these are all which improves the strength of that particular member. Okay, so improves performance in terms of resilience. What do you mean resilience? As we already discussed, so resilience is nothing but energy stored in a body to regain its original shape and size. So that is how, due to the pre-stressing concept, we can make member more resilient. Okay, under even dynamic and fatigue loads also, right? And the high span to depth ratio. So with this pre-stressing technology, you can go with long spans, and even you can go with the column free spaces, right? And it is suitable for precast construction also. So nowadays, as I told you, sleeper is a precasting element. Partition walls, partition panels are all precasting elements. Retaining panels are precasting elements. Okay, electrical poles are precasting elements. So if this pre-stressing, particularly this pre-tensioning, is most adaptable for precasting construction elements. Okay, so which makes your construction more rapid, so for better quality, and it will reduce maintenance. Okay, so it is very suitable for repetitive construction, and which is available in different shapes of concrete. Okay, so why we are going with concrete? Why? Because concrete, where we can mold into our defined shape. Okay, so that's what more advantage in precast construction. So where we can go with our defined shapes. Okay, so that is what exactly the advantage is. So let's start with our topic today, so which is the types of pre-stressing. So in the yesterday's session, so we discussed the types of pre-stressing in terms of system, like pre-tensioning and post-tension. So today we are going to discuss the types of pre-stressing in terms of mode, in terms of application. Okay, what are the ways you can do the pre-stressing? Okay, so these are the sources of pre-stressing force. So the force which is applied to the tendon in terms of tension, so that it can able to done in three ways. Okay, the first one is hydraulic pre-stressing, and the second one is mechanical pre-stressing, and third one is electrical pre-stressing, so which is called thermo-electrical pre-stressing. Okay, very important, Amma. Don't confuse. If they ask you system, you can write pre-tensioning and post-tensioning. If they ask you types of pre-stressing in terms of force, you can write these three: hydraulic pre-stressing, mechanical pre-stressing, and thermo-electrical pre-stressing. Okay, so let me show you videos of how the hydraulic pre-stressing works, how the mechanical pre-stressing works, and how the thermo-electrical pre-stressing works. Okay, then we will discuss in detail. Okay, so here in this video, I am trying to show you how the hydraulic pre-stressing done. So you can see this is the mold. Okay, so they want to cast something in this mold. So before placing concrete in this mold, what they are doing, they are inserting a wire. Okay, it is not a strand. Why? Because it is only single piece. So by that, this is called a wire. Okay, and the wire was placed, and the wire now they are pulling with the help of hydraulic jack. This is called hydraulic jack. See, so it is pulling the strand. So it is pulling the wire. So this will be happen on both sides. Okay, so like that, you have to go with the two hydraulic jacks, or one on either side of the particular mold. Okay, so this is how the hydraulic stressing will be happening. So this hydraulic stressing is majorly used for concrete sleepers, electrical poles, compound walls, railway sleepers. Okay, and so this is how the tensioning of steel wires are supposed to be happen, right? Okay, so let me show you the next video, so which is mechanical, sorry, there is no video for mechanical prestressing. So let me continue the presentation and I will show you the other one. So hydraulic prestressing. So just now we gone through the video. In that they are using some hydraulic jacks to stress the wires or to stress the strands, isn't it, on either side of the mold, right? So what is the what do you mean hydraulic prestressing here? This is the simplest type of prestressing. So where it is going to produce large prestressing forces, right? So the hydraulic jack, which is used for the tensioning of tendons or tensioning of a wire, because I already told you wire winding all wires together, it's called a strand. Okay, so bunch of strands we call it as a tendon, a group of tendons we call it as a cable, right? So like that. So here jack, which is used for the tensioning of tendons, comprises of calibrating pressure gauges, so which directly indicate the magnitude of the force developed during the tension. So here you may ask me question, sir, how much force they apply to pull the strands? See, that force will be designed in prestressing. Okay, so that is what IS 1343/2012 will use the design of the prestressing force also. Okay, so with that force, so we are going to calibrate the pressure gauges. So where we are going to indicate that particular magnitude of the force which we are going to apply on the particular wire or particular tendon. Okay, so this is what the hydraulic prestressing. So let me show you the next prestressing, which is the mechanical prestressing. Okay, so earlier the prestressing was done by whom? By a person with the help of a jacks. So here it's a mechanical prestressing. In this type of prestressing, the devices which are includes weights with or without lever transmission. Okay, so here you can see in this picture there are two ends. One is dead end, the other one is live end. Okay, in the dead end there is a mechanical device, even in the live end also there is a mechanical device. Okay, so here the load cell will be there. You are and the member they are supposed to be stressing is a reinforced concrete beam. Okay, so this is the CFRP sheet. So they are they placed on the top of the reinforced RCC beam. So this beam they are doing mechanical prestressing with the help of some mechanical devices on either side of the beam. Okay, so this is how they do. And for this there will be a lever, there will be a lever transmission, there will be a geared transmission, so which is going to be conjunction with the pulley blocks. Okay, and there will be screw jacks with and without gears. There will be a wire winding mission. Okay, here whatever the wires placed in the beam, so that wire is going to be winded with some winding missions. Okay, so this type of prestressing is adopted for mass scale production. So for example, there is a huge production of precasting slabs or precasting panels. Okay, so there they're going to use this mechanical prestressing. Why? Because for the mass scale of production, one alone can't do stressing for number of units, right? So for doing this mass scale of production of elements, so what they do is they will go for mechanical prestressing, where it can be done by mechanical. Okay, so as I told you, in Hyderabad there is a company called Preca, so where they are casting lot of slabs, beams and precasting panels and all. So they are using mechanical prestressing over there. Okay, so because it will reduce the manpower. Okay, so this is how the mechanical prestressing is going to be done. And next one is electrical prestressing. So the electrical prestressing is nothing but thermo-electrical prestressing. So here what you do, so here the steel wires or whatever the strand which we are using for stressing, so that wires are supposed to be electrically heated. Okay, they will heat first, electrically heated and anchored before placing concrete in the mold. So this electrical prestressing majorly it will be done only in pre-tensioning system. Okay, not in the post-tensioning system. Understand? Okay, carefully understand. So this electrical prestressing is adoptable for pre-tensioning. Why? Because there is no concrete is placed when the wires are tensioned in pre-tensioning system. So where you can able to heat the strand or a wire. So by that these steel wires are electrically heated and anchored before placing concrete into the mold. Okay, so this type of prestressing is known as thermo-electric prestressing. Okay, so why? Because so when it is electrically heated, the rod will have a tendency to elongate, isn't it? So when you heat the rod, so it will lose its elasticity and it can able to elongate as much you can. So in that way it can be improved its it can be stretched as much you can. So in that way, this thermo-electrical pre-stressing can also be used for pre-tensioning system. Okay, so let me show you one video. So how the electrical pre-stressing can be done here. Yeah, thermo-electrical pre-stressing. So here you can't see exactly how the member was thermally melted, but you can observe the video how it can be happen. Okay. There is a precasting mold. So in that mold, all strands are placed, all wires or strands are placed, okay, on two different rows. This is how they are pulling. So here, while pulling, what they do, they will do thermo-electrically heated. They will heat the particular rod with some electrical device. Okay, in that member can easily be elongated. See, it was placed on vibrating table. So where they placed this precasting mold, they placed on the vibrating table. Why? Because when they pour concrete into that particular mold, concrete should get packed in the mold without any voids. Okay, so by that they do vibrating. They won't use vibrators. They use a table vibrator to spread the whole concrete within the mold. See, try to observe my arrow, mouse arrow, okay, or mouse cursor. These are called anchorages. These are called anchorages. Okay, so this anchorage will hold the wire after applying tensile force. Okay, the anchorages will hold the wire. Okay, so because after casting, after attaining its strength, what they do, we will cut the members, right? So before they cut, they are supposed to be anchored on both ends. This language is in what they are doing. They are doing warm curing. Understand? So they are doing warm curing over there to get it set quickly. That's it. So this is how the thermal electrically stressing can be done, right? Let me go back to the presentation. Yeah. So that is what hydraulic pre-stressing, mechanical pre-stressing, and electrical pre-stressing. Okay. So next. So what are the different modes of pre-stressing, like where the stressing can be done? It can be done in both ways. One is external or internal pre-stress. Okay. So let's talk about external pre-stressing. So what do you mean external pre-stressing? The stressing which was done away from the section, like away in the sense from the outer portion of the particular element. Okay. So here the external stressing here in the sense when the stressing is going to be achieved by elements so which are located outside the concrete. Okay, so that means the depths or the stressing outlets so will be present outside the concrete. It won't be within the concrete, it will be outside the concrete. So it is called external stressing. Okay, we do stressing externally. So the tendons which can lie outside the member, okay, so they are going to be stressed externally. So let us take an example of girder or eye girders or even the walls. They are all externally stressed. Okay, externally pre-stressed, right? Or you can take even the hollow space of a box girder. Even in the box girder, you can see the stressing which was done externally. So within the cell, okay. So the box girders will be like a single cell box girder, double cell box girders, triple cell box girders, like that. So within the cell, inside, they do stressing. Okay, not within the section, they do away from the section, right? So these kind of stressings are called external stressing. So this technique is majorly adopted in bridges particularly, and the strengthening of buildings. Okay, so in the retrofitting technique, if you want to strengthen the particular element, like if you want to strengthen the beam, if you want to strengthen the column, okay, in the retrofitting technique, they go for external stressing like this. Okay, so in the following figure, you can able to observe how the external stressing can be done. So I will try to show you one picture. See, this is called single cell box girder. So in the single cell box girder, you can see the strands, right? So you can see the strands. So whenever you can able to see the strands, see the that stressing profiling and all, so that is particularly called as external stressing of a box girder. Okay, so internal stressing means you can't see them. There will those stressings will be happen within the section local ఉంటుంది. Even the duct also will be placed inside the concrete. Okay, so like that, the external pre-stressing of a box girder is an example. So let me show you one video how the external stressing will be done. See, this is a bridge. What is this? This is called a soffit of a bridge, right? Soffit and endama bridge kinda portion is soffit under. Okay, so when you want to strengthen the bridge, right? If you want to strengthen the bridge, you can do external stressing to increase the bearing capacity of that bridge, load carrying capacity of that particular bridge or a particular girder. Okay, in that way, the external stressing can be done. Okay.
确保扎拉端毛块能在纤维框内自由跑动。悍马碳纤维板的裁剪长度，两端可运用将焊板装入毛具切形孔内，滑动扎拉端毛块至起始位置，用夹具夹紧，在扎拉端依次安装高强度杆、垫片、挡板、前进力。
So that is called hydraulic jack. So they are using jack to do the external stress. Okay, for the stressing, what they use a strip, metal strip.
扎拉切粉后，在焊板表面均匀涂抹焊板胶，随后进行初级整体扎拉。每级扎拉后需时隔35分钟。
See, they are doing tension, right? So they are pulling the strands. So by that, that strip will try to push the girder towards upward direction. Okay, by that, the carrying capacity of the member or the particular girder is going to be increased, and then it is going to be anchored to the concrete. Even you can't see them, why? Because they do plastering of that. Okay, so this is how you can able to increase the bearing capacity of that particular segment or particular bridge, right? So that is what an external stressing, right? External stressing like the pre-stressing. Okay, so let me show you internal pre-stressing. What do you mean internal pre-stressing? So what are the examples we have seen in girder and all? Okay, so where they do stressing inside the concrete. Okay, so when the pre-stressing is achieved by elements which are located inside the concrete member. Okay, so which is commonly by embedded tendons. The tendon or a wire or a strand, everything will be placed inside the concrete. So it is called internal pre-stressing. So here the most of the applications and most of the industrial applications of pre-stressing are internal pre-stressing. Okay, so external pre-stressing can be done only to strengthening the member, to retrofit the member, right? So to increase the carrying capacity of the member, I mean load carrying capacity of the member, then only for that particular purpose they use external prestressing. So rest of that major applications they do internal prestressing only. So you can find internal prestressing like this. So the same segment, okay, you can do the you can observe the profiling, cable profiling, which was inside the concrete, right? So this is the internal prestressing of the box girder. Okay, so let me show you a small video of the internal prestressing of a box girder also. So you can just see how the internal stressing can be done. See, this is a pre-casted, pre-casted longitudinal girder. So where the stressing will be done from internal, right? So you can see the profiles, you can see the sheathing pipes, which was placed from one end to other end in a form of a profile, right? So can you see the stand over here? No. So because stands will be placed inside the concrete, so where they are going to be stressed. Okay. So if you try to see them practically, so I think you can able to relate them with the typical concepts easily. Okay, so whenever I take you to industry visit, I will try to explain everything over here. Okay, this is called end block and this is called intermediate block, right? So these pipes are used to fix the shuttering. Okay, so that's how they use this small pipes over there. So this reinforcement is called a diaphragm reinforcement. Okay, so everything you can try to observe when you see them practically. Okay, so this is how the internal stressing can be done for the bridge elements like the girders, okay, longitudinal beams and all. So where they do stressing from internal, right? So that's it. So this is what's about internal pre-stressing. Let me go back to the presentation. So, okay, so I think you all had a view of what exactly the external prestressing and internal prestressing, right? Okay, so next, so there is a other way of doing prestressing. So based on the type of element, okay. So if the element is a longitudinal member, so they do linear prestressing. If the member is like a circular member, they do circular prestressing. Okay, so in that way also prestressing will vary. Okay, so there are two types of stressing. One is linear, the other one is circular prestressing. So let me talk about the linear prestressing. So whatever the examples we've seen till now, they are all linear prestressing. Why? Because the member is longitudinal. So where we are doing stressing in terms of in its longitudinal length, right? So the prestressing members which are straight or flat in the direction of stressing, okay, the prestressing is called linear prestressing. Okay. So what are the examples of all this linear prestressing? You can tell all examples which was which are the examples we seen till date. Like prestressing of beams is a linear prestressing. Prestressing of piles is a linear prestressing. Why? Because pile is also a vertical member. Pole, electrical poles are a linear prestressing. Slabs are all linear prestressing. Okay. So the profiling of these prestressing are going to be, okay, I mean the tendon is going to be in curve. Okay, so we will make that in a form of a sagging curve ga manam place chestam, then we do stressing and it will become straight. Okay, so the following examples like railway sleeper is also best example of linear pre-stressing. Okay, so then so in this picture you can see linear pre-stressing which was done for railway sleepers, so where we do pre-tensioning of these members. Okay, railway sleepers, it is also a linear pre-stress, right? I think you can relate what exactly the linear prestressing with the help of pictures. And coming to the circular prestressing, can you tell me where we use the circular prestressing? So we use this circular prestressing where the element is in a form of a curved shape. Okay, so when the prestressing members are curved, so the direction of stressing also will be in form of a circular way. So that's why it is called a circular prestressing. So what are the examples of circular prestressing? So here in linear prestressing, we do stressing longitudinally, right? But in circular prestressing, we do stressing circumferentially. Okay, we do along its circumference. So the best examples of this circular prestressing is water tanks. So why? Because there will be circular water tanks. So we do stressing, circumferential prestressing, and silos. Okay, what do you mean silo? So if you observe them in ready mix concrete plant where the cement is going to be stored in a huge hoopers, so they are called silos. Okay, and pipes, and you know what do you mean pipes? So for example, you know water pipes, water CC pipes will be there. Okay, so for you know so there will be a water pipeline where the water pipes are going to be casted with concrete. So they are all circular pipes and similar like kind of structures like shells. So all these are not in a regular linear position. They are all in a curved shape. So where they are supposed to be stressed in a form of a circular stress. Okay. So you can see example here. So this is the best example, circular prestressing. So which is a containment structure. Okay, water containment structure. Even the nuclear power plant, it is also in a form of a curved shape, right? So conical shape kind of thing. So where they are all supposed to be circular prestressed. Okay, so this is the modes of doing prestressing. Yeah, either they are doing pre-tensioning or post-tensioning. No, no bother. So here you have to try to observe what type of stressing is adoptable for that particular element or structural element based on its shape and based on its mode of behavior, mode of doing the stressing. Okay, so there you have to decide whether you want to go for hydraulic stressing or mechanical stressing or thermo-electrical stressing, or else linear stressing or circular stressing. So that you have to decide, okay, before you do either pre-tensioning or post-tension, right? So this is what about the types of stressing systems. Okay, so here you have to understand even the stressing, the concentration of stressing. So concentration of stressing in the sense whether you are doing full pre-stressing or limited pre-stressing or partial pre-stressing. Okay, that is also very important because every element doesn't require full pre-stressing. Okay, full pre-stressing in the sense you are going to apply force with a full magnitude. Okay, it doesn't require. So maybe some elements required only a partial pre-stressing. Some elements may require only limited pre-stressing. Some elements may require full pre-stressing. Okay, so if you do partial pre-stressing now, in future if you want to increase the strength of that particular member, you can do further pre-stressing there. So that is how partial pre-stressing is going to be done for few elements which to be done in later of times to improve its strength. So like that, stressing can also be done in three different modes. One is full, other one is limited, and third one is partial pre-stressing. Let's go with the full pre-stressing. So what do you mean full pre-stressing? So here the level of stressing is such that no tensile stress is allowed in concrete under service loads. So that is what exactly the pre-stressing, full pre-stressing means. Okay, so what do you mean limited pre-stressing? So here the stressing which is supposed to be done for the strands or tendons, the tensile stresses under service loads within the cracking stress of the concrete. Okay, cracking stress of the concrete. So it is called limited pre-stressing. And next one is partial pre-stressing. What do you mean partial pre-stressing? So you are much bothered about the tensile stresses due to service loads. The crack width is within the allowable limit. Okay, so when the crack width is within the allowable limit, you can go for partial pre-stressing. Why? Because if you go beyond that, maybe the member may get failed immediately. So that's why for those kind of members, you require only partial pre-stressing. Okay, so when you want to see the member under full service loads, so then you can go for full pre-stressing. Okay, so within the cracking stress, if you want to do, you can go for limiting pre-stressing. So like that, you have to decide what type of, what the mode of stressing, what magnitude of stressing you have to do for the particular element also you need to decide. Okay, full, limited, or partial. So that is how the three modes of stressing. Okay, so can also be that. And the other one is uni-axial, bi-axial, or multi-axial stressing. Okay, what do you mean this? So in the examples which we've seen, so in that examples you can relate this uni-axial, bi-axial, and multi-axial prestressing. So what do you mean uni-axial prestressing? Uni-axial prestressing in the sense there will be only a single wire. Okay, so there won't be any multiple wires. Okay, if you see the member which was stressed with the help of a single wire, in the first video you have seen, right? So it is called uni-axial prestressing when the prestressing tendons are parallel to one axis. Okay, all the members which are parallel to only one axis, so it is called uni-axial prestressing. For example, if the member if the member was stressed within the same axis, okay, if you take either y-axis or x-axis, so you tell me this video, okay, by seeing this video, whether it is uni-axial or bi-axial. Let me show you this. Yeah, this one. Tell me this. So this is pre-stressed concrete girder, right? So what type of stressing it is? Is it uni-axial or bi-axial? See, if you take y-axis, so all cables are placed within the axis, right? So these are called uni-axial stressing, right? So like that. So the stressings are defined. Okay. See, if the stressing are parallel to only one axis, so it is called uni-axial stressing. So for example, longitudinal pre-stressing of beams. So that is what I'm talking about, right? If you take beam, so when your beam is longitudinally stressed, so it is comes under the uni-axial pre-stressing. What do you mean bi-axial pre-stressing? The best example is slab. Why? Because slab is having a huge width and length, right? So here you are supposed to do biaxial pre-stressing, so where the pre-stressing tendons are parallel to two axes. It is not only for one axis. So when the tendons are parallel to two axes, it is called biaxial pre-stressing. Okay, the best example is pre-stressing of slabs. Okay, beams comes under uni-axial stressing, beams or girder, whatever it is. Okay, and slabs comes under biaxial stressing. And what is the third one? Multi-axial pre-stressing. What do you mean multi-axial pre-stressing? So when the stressing tendons are parallel to more than two axes. One axis, it is uni-axial. Two axes, it is biaxial. Multi-axial means more than two axes. So it is called multi-axial pre-stressing. Example is the dome. So dome is something like a 3D, element, right? So it will have more than two axes. So that kind of members comes under, comes under the more than two axes, where you have to go with multi-axial pre-stressing. Okay, the best example for them is domes, curved domes. Okay, so like this, even the stressing is classified in terms of, pre-stressing was classified in terms of uni-axial, biaxial, or multi-axial pre-stressing. Okay, so that is what about the different types of stressing systems. Okay, so I think we already discussed about pre-tensioning systems and devices in the previous class. So what do you mean pre-tensioning system? So it is nothing but tension is applied to the tendon or a wire before casting of the concrete, isn't it? So that is what a pre-tensioning system and devices. So here you have to remember what are the stages of pre-stressing. That is very, very important. Okay, so in the previous class, we just gone through what do you mean pre-tensioning, what are the examples of pre-tensioning, and how it can be done. So here the stages of pre-tensioning, please, we will go through here. So the various stages of pre-tensioning operations are summarized here. So like first one, anchoring of tendons against the end abutment. Okay, so here please try to look at this video again. By that you can relate all these stages of pre-tensioning easily. Okay, so let me show you the video again. So now please try to observe this video carefully and relate all the devices which were used in pre-tensioning. Why? Because this video is internal pre-tensioning, isn't it? So this is pre-tensioning, which are made up of hydraulic pre-stressing, right? So please try to relate all the devices which are used in pre-tensioning over here. Okay, see, there is a mount and there is an anchorage wire, and they are fixing that wire with a wedge. So this is called wedge. Okay, so please observe this. This is called wedge. Okay, so what wedge do? Wedge will hold the wire. Okay, wire ni hold chestun anamata wedge. Okay, so there will be different types of wedges anamata. I will try to show you different pictures also. So there will be two pin wedges, 3-pin wedges untai. So the wedge, what is the purpose of the wedge? Wedge will hold the wire. Okay, okay, there are two anchorages on either end and the hydraulic jack, and the jack is used to apply tensile forces, isn't it? Observe, right? So this is what they are doing the pre-tensioning over here, right? So now let's come back to the presentation. Now see all the devices for pre-tensioning. See all the stages of pre-tensioning. So what is the first one? Anchoring of tendons again is the end abutment. So end abutments means on either end. Okay, both ends they are abutments, so which are going to be hold. And second one is placing of jacks. So you're going to place jacks on either side of the mold. And third one is applying tension to the tendons. What they are applying tension to the tendons. Fourth one is then after they will cast the concrete, okay, into the mold, and finally they will cut the tendons, isn't it? So finally they will cut the tendons, and the whatever the tension we applied in the tendon, it will release the forces which makes concrete to squeeze, which makes concrete to have a compression stress into it. Okay, so that is how the stages of pre-tensioning is clearly explained here, right? Next, so you can see, observe even in the pictures also. So now placing a strand and applying a tensile force, and then casting of concrete, and then releasing, and then you are cutting the strands. Okay, these are called abutments. This is our end abutments. So when you cut the strand, the rod will try to compress. So it will release the forces into the concrete, where the concrete will get squeezed and become as a hogged member, right? So these are the stages of pre-tension, right? And next one, advantages. What are the advantages of pre-tensioning? Here the relative advantages of pre-tensioning are: one is pre-tensioning is suitable for precast members. Very, very important. Okay, so because whenever you go for interviews, they may ask you, so tell me a few examples where you can go for pre-tensioning. Tell me a few examples where you can go for post-tensioning, right? So you can tell very clearly all precast members which are going to be produced in bulk, like electrical poles, railway sleepers, precasting wall panels. Okay, they're all comes under the precast members which are going to be produced in bulk, right? And the next one is, in pre-tensioning, large anchorage devices are not present. Okay, so why? Because with one anchorage device you can do multiple pre-tensionings over there. So that's the biggest advantage of pre-tension. Okay, and what are the disadvantage of pre-tensioning? So that is the reason why we are going for post-tensioning. So what are the disadvantages? So a pre-stressing bed is required for the pre-tensioning operation only. You can't go post-tensioning with that same bed. Okay, that is a disadvantage. And next one is, there is a waiting period in the pre-stressing bed before the concrete attains a sufficient strength. That is the biggest disadvantage. Why? Because you are placing that concrete, okay, on the same platform for 28 days. So by that you can't use the same platform again. You can't use the same abutment platform again. Why? Because so where the concrete is supposed to be attained full characteristic compression strength, so by that you can't reuse the same platform again. So that is why there is a disadvantage of pre-tensioning in terms of waiting period. Okay, where you can make use of the pre-stressing bed to the other casting elements, right? And there should be good bond between concrete and steel over the transmission length. So what do you mean that? See, let's see the same image. So if there is no bond between the strand and the concrete, if it's only red color, only the strand, right? Strand or a wire, and this is the concrete. If there is no bond between strand and wire, so obviously your concrete can't able to carry the compression forces which is going to be induced from the strands. Okay, so there should be a proper bond. By that, before going to the application, you have to make sure what is the bond strength of this wire or the strand to the concrete, and the bond strength కూడా మనం check చేయాలి. Okay, so bond strength is very, very important. If there is no proper bond strength, so by that the load can't be carried, the transmission length can't carry the load. Okay, that is the disadvantage. So you can try to observe the pictures over here. Traveling pre-tensioning stress bench, this is the bench, this is the mold, and this is the abutment where they are doing pre-tensioning, and this is called anchoring of strands. So where the strands are going to be anchored over here, right? And here you can see stretching of strands with the help of hydraulic jack. Okay, so it's here, so this is called hydraulic jack. Okay, and pouring of concrete. So after stressing, so you're going to pour concrete into the mold, and then you are going to do steam curing chamber. Why steam curing? So because if you do water curing, you should wait for 28 days. Okay, when you are producing bulk elements, bulk production, so you can't wait 28 days of each mold. Okay, you if you want to make use of the mold for multiple purposes, you should not wait for 28 days. By that you can go for steam curing, so where you can remold the element, okay, within the time, like within 1 or 2 days you can remove it easily. So that is how they go for steam curing chamber, or where to use the same platform for other elements. Okay, so this is how the pre-tensioning is done, and the best example you can see the demolding of the sleeper, and this is the storage of the sleepers. Okay, so all the railway sleepers are pre-tensioned like this. Okay, what is the time now? Yeah, so 13 minutes left. I will try to close this, and we will discuss the materials in the next class. And next one is post-tensioning systems and devices. So, okay, now we have seen what are the pre-tensioning systems and devices. Now let me show you what are the post-tensioning systems and devices. Okay, so in the post-tensioning system, so the tension is going to be applied to the tendons after concrete attaining its strength, or after concrete getting hardened, right? So that is how the post tensioning system and devices. And let's see what are the stages of post tensioning. So here I think you can able to relate few videos which I have shown in the previous presentations, so where this post tensioning is how it was happened, right? So please try to relate these stages over here. So the first stage is casting of concrete. In the mold, first we have to cast the concrete. Before casting concrete, what you have to do? For doing stressing, you have to provide a sheathing within the concrete, that called hollow pipe, okay, which we called sheathing. So that sheathing is going to be provided within the concrete, and then in that pipe you are going to place the tendons, right? And the placement of the anchorage blocks and jack, applied tension to the tendon, sheathing of the wedges, and cutting of the tendons. So that's it. So the only difference in pre-tensioning and post-tensioning is, in pre-tensioning, before casting of concrete you do tensioning. In post-tensioning, after casting of concrete they do tensioning. Okay, that is the only difference, and the rest of all the stages will be almost the same from the third stage. Okay, the first two stages will be slightly different. Okay, so let me show you in few images how the post tensioning can be done. So this is the casting bed, right? And how the casting of concrete is going to be done by placing a duct within the concrete. What do you mean duct? Duct is called a hollow pipe, hollow sheeting pipe. So while casting, they are going to provide the hollow sheeting pipe within the concrete. Okay, and then they are going to cast the concrete. After casting, after concrete attaining its 28 days characteristic compression strength, so what they do, both ends they will do anchor. Okay, after anchoring, so the stressing can be done on both sides. Also you can pull the strands, or what you can do, you can fix one end, that we call it as an anchoring, and from the other end you can do stressing. Okay, so but in bridges what they do, they go for stressing on both sides. Okay, two sides which is stressing chester. Okay, so where it will have a uniformity, right? So but for few elements, where for small elements what they do, they will do anchoring at one end, and they pull from the other end. Okay, that is one way of doing another, right? So that is how. And finally the anchoring the tendon at the stretching end. So what they do, and finally they will cut even the other end also, and then the concrete will get squeezed, and the concrete will be induced with huge compression stresses. Okay, so this is how the post tensioning stages there. And let's see the advantages of post tensioning. So here there are a lot of advantages compared with the pre tensioning. Here the relative advantages of post tensioning are, first one is post tensioning is suitable for heavy cast in situ members. Very important, like girder. Okay, like girders in the bridges, they are all very heavy, and they are supposed to be cast in situ. Okay, so whatever the girder which I showed you in the video, they are all cast in situ. Okay, so where they are casting at the same place. Okay, over the piers, pier caps, they want to cast the member there itself, and they do post tensioning. If you see even our LNT metro, all the viaduct, all the segments which are pre-tensioned segments, after launching, So they will do post tensioning at the place itself. Okay, so like that, post tensioning is suitable for heavy cast in situ members, so which is specially used for box girders and heavy box girders, and the waiting period in the casting bed is very less. Okay, so here you can make use of the bed very easily. Why? Because after casting you can shift the member to the other place and you can do tensioning. Okay, you no need to wait for 28 days on the same platform where it will be holded there, right? Or where it will be held up there, right? In that way you can make use of the platform in for other elements very easily. Why? Because after casting, after within 3 days you can shift the element to the next bed, right? And the transfer of prestress is independent of transmission length. So here, as we spoke about pre-tensioning, where bond strength should be there, concrete and steel should have a good bond strength to have a transmission length. But here no need. Why? Because there will be a sheathing pipe inside, no need of any bond between concrete and steel. Why? Because you are doing stressing, okay, independently uh, on the particular strand or tendon. So that is the reason where there is no point of bond strength over here in between concrete and steel. So that is the advantages of post tension, right? And as we spoke about the devices, so the devices which we used for post tensioning are casting bed. You require a casting bed. Second one is mold or shuttering, okay, to cast that particular girder or a beam in a shape of a rectangular shape or a ice shape or a T shape. Okay, you require a mold, isn't it? That we call it as shuttering. Mold and shuttering and okay. And third one is duct. What do you mean duct? The pipe which you are going to provide within the concrete, that is called duct. Duct and sheeting and okay, sheeting. Okay, so it is called hollow pipe and we call it as a duct technically. We should not call it as a pipe. We should call it as a duct or sheeting. And the fourth one is anchoraging devices. You require anchoraging devices to fix at one end. Okay, or sometimes you no need of anchoring at one end, so you can do stressing from the both ends. And the fifth one is jack. You require jack to apply tensioning to the strand. And sixth one is coupler. You require couple. Okay, you require couplets to fix the strand in a position. And seventh one is grouting equipment. As I told you, after doing stressing, what they do, that pipe is supposed to be filled with some cement slurry. Okay, so otherwise what happens, your strands will be idle inside. So it is supposed to be filled with some cement grouting material. Okay, so that is how the grouting equipment is also required for post tensioning. In pre tensioning, not required. Why? Because in pre tensioning, strand and concrete are both are bonded together, but in post tensioning there is no bond between strand and concrete. So there is a gap between strand and concrete, so where the pipe is, where the duct is supposed to be filled with some cement slurry. So like that, grouting equipment is also needed for post tensioning. Okay, so like this. So here you can see the different material. Like this is called bearing cones, and this is what sheeting or duct. This is called trumpet, strand, wedges. These are all wedges, and this is called anchorage head, right? So this is called anchorage head. So you can see all this. Okay, don't worry guys, I will try to show you all this practically by taking you to industrial visit. Okay, because there are a lot of post tensioning and pre tensioning is happening in Hyderabad in many infrastructure projects. Okay, we can go to industrial visit and we can try to observe them lively, right? So like this. So this is called girder. See, so after casting it will be like before casting. See how the girder was how the duct was placed within the reinforcement. See, there are 4 different stages where the sheathing or duct are provided, okay, in a parabolic shape. Kada? So it is not straight, they are all in a parabolic shape. Why parabola? Everything we will come to know in the design. Okay, so I will try to show you one model, okay, which was developed by me, where you can able to see how the post tensioning how the post tensioning can be applied, and you can see how the member is going to be hogged towards upward direction. Okay, so this is the first stage of post tensioning, where providing sheathing inside. After that, it is going to be casted with concrete, okay, on the casting bed, and then finally after attaining its 28 days strength, it is going to be stressed with the hydraulic system, right? So these are the stages. Okay, So I think we won't have enough time to discuss about materials. We will try to discuss this on Saturday's class. Okay. So sorry guys. So now we are having only 4 minutes time to discuss doubts. So if you have any doubts, so please you can ask me. Please guys, any doubts? Students, are you there? Any doubts? No doubts. Shall we wind up session? We have next class. Yeah, I know, Mithun. Let me close within 2 minutes. So any doubts, guys? Mithun, I want others to answer. Okay. Others can also respond, right? I know you won't have any doubts, but what about others? No,
No
sir, all
doubt, sir.
clear. Okay. What about others? See, there are around 30 students. Is external stressing only structures, sir? Exactly. Good. Industry, external stressing is only can be done for existing structures only. Okay. You can't go for for newly casted elements. Okay. For existing and for old structures, to increase its strength, to increase its load carrying capacity, you will go for external stressing. Okay. Okay. Anyone else? Any doubts? Okay. So 3 minutes left. We have only 3 minutes for doubts clarification. Within 1 minute, I will leave. Okay. You will have 2 minutes to access to the next class. No issue. Anyone? So I hope today's session is very clear in terms of knowing about different types of pre-stressing systems, right? Isn't it? Like devices, modes of pre-stressing, okay, types of pre-stressings, right? Fine. So no doubts, right? Okay then. Thank you so much. So let's see you on Saturday, where we are going to discuss about materials. Okay. So I request you guys, so please go through these presentations again. Okay. If you have any doubts, so please note them and you can ask me on Saturday. Okay. For the first 5 to 10 minutes. Okay. We'll have a discussion there on Saturday. Right. Okay then. Thank you.